Hello, everyone. I'm Seth Grimes. This is a talk on emotion AI. It's a topic that I've seen come up only very much in passing in earlier talks today. So this is going to be a technology talk, but not overly technical. I'm glad to see that some of the other speakers already have talked about text analysis, voice analysis, and so on, because this topic, emotion AI, builds on those technologies, and I don't have to cover them. So myself, I'm from the United States. I live near Washington, D.C. Some of the activities I'm involved in include consulting. I have a consulting company, Altiplana. I run a couple of meetups in the United States, natural language processing meetups in New York and in Washington, D.C. If any of you are into NLP and visiting the U.S. and want to speak at one of the meetups, you should send me a note. I also run some conferences. I have one coming up in 3.5 weeks in New York on the emotion AI topic, although I've already learned from Moshe Wasserblatt from Intel that he will not be able to make it because of coronavirus, so we'll see. So I'm going to talk about the foundations of emotion AI. I'm going to talk about models. I'm going to talk about applications that draw on emotion in different sorts of human communications. I'm not going to talk in any great depth about the motivations. I'll just say that we take it as given that emotion underlies all of our decisions as humans, and therefore, if we want to automate business processes to work at scale quickly in languages and cultures other than our own personal ones, we turn to artificial intelligence, and it is essential that we understand the emotions and related concepts such as empathy and intent, the human elements of communications, and we model them and emulate them in machines. The first usage of the term emotion AI that I have seen was about 12 years ago. I have it on the screen here. This was an effort that did not move forward. Sometimes the intention, what we want to do, comes up in advance of the marketplace and also in advance of the technology. The technology is not yet powerful enough to do what we want. The data might not be available, but also the market is not quite ready. So just an example from 12 years ago, the first occurrence of the term emotion AI that I've been able to find. Let's try it this way. Emotion AI as a computing discipline is it's related to affective computing. This is a field pioneered by Professor Rosalind Picard at MIT Media Lab. I have her on the screen with a quotation. I will read some of the quotations that I have, but not all of them because I use a lot of them. But the idea is that if we want computers to be genuinely intelligent, to adapt and interact naturally with them, then we have to understand emotions. Now, Roz is in particular working on wearable technologies for things like early detection of seizures, of medical conditions, by measuring body signals. This is one of the sources of emotion and one that she focuses on. So she did write this book in 1997, so going back 23 years on affective computing. I will provide my slides on SlideShare if they're not available through the conference so that you can review them yourselves and read this text yourselves. So I'll go back even further than 1997 to talk about Bloom's educational taxonomy, where Bloom, the author here, sees a differentiation between affect, motor, and cognitive capabilities. So companies such as IBM in particular have talked a lot in recent years about cognitive computing. That is about building reasoning capabilities based on facts found in data sources, via computing models, cognitive models, but we recognize that emotion is something different from the rational that is attacked by cognitive computing models. Still, what we're about in affective computing is trying to make rational what is irrational, what is emotional in human thought and communications and actions. So we do see this sort of breakdown between cognitive, between physiological, the body states, and emotional, going back historically well before computing. And it is a breakdown that works today. And what we're trying to do is to synthesize the elements from each of these streams in affective computing and emotion AI. A couple of quotations here. Blaise Pascal, Le corps a ses raisons que la raison ne connaît point. The heart has its reasons that reason knows nothing of. The idea is that we're trying to, again, turn the power of computing, using data, using machine learning technologies into something computable. And then a quotation from the famous statistician George Box, all models are wrong, but some are useful. So toward the tail end of my talk, I'll talk about some of the disputes about emotion computing models. And the idea here is that we have iterative processes in computing where we realize that what we're doing is inexact, but still it is very useful, and the technology advances toward our goals. It's inexorable. I'll try not to use words that some of you might not understand. So let's talk about emotion models. We see a number of them. They're very colorful, that have a broad variety of emotions. They arrange them in a graphical form that, well, we have proximity of one emotion to another that's represented here. This is the Geneva Emotion Wheel at an academic center in Geneva. We do see a lot of academic work in emotion modeling. At the same time, a lot of the innovation is going on in private companies, which probably most of you represent, trying to make something out of these models that is very useful for business, for research, for security, for governmental purposes. A model that is very commonly used is the Plutchik star model here. I have two different representations of the same model. These representations show a number of things. You look at the star model in particular, and you go outward from the core. We have three different levels. The models are hierarchical. They have different levels of refinement. And then we see certain elements that bridge I'll call it the petals of the star, as if it's a flower has petals, that bridge these. So we do have a certain complexity here. The first complaint I will make about this is that we see an English language set of emotions here, and there's a challenge here with bias in AI in general. Is the modeling that is going on here prejudicial to English language thinking? Language represents the way that people think. It represents cultures. If you were to do something native in Hebrew or some other language, you would not have the same model here. So we do have a concern, as in all areas of language computing, about how can a model that was originated in one language and one cultural context translate into another. We've had talks here at this conference about Hebrew language NLP, so this is a very relevant question. Bias underlies all of what we're doing. Bias is especially prevalent when we're talking about very human artifacts, about the way that people feel. Here's another representation of the Plutchik model. It is just a different topography for it, but I bring this one up in particular because it is put forward by an academic named Eric Cambria, who has been at various institutions, but for a number of years he has been in Singapore, and he's developed something called Centik.net. Wherever possible, I will give you references that you can go out on the web and find these things yourself and learn from them. So the Centik.net work is very interesting. It attempts to create actual practical software implementations for sentiment analysis and then bridging that into emotion. But let's talk about sentiment analysis a bit. So I, in my first slide, showed emotion AI from 12 years ago, and I said that it was really premature, both in terms of computing power and in terms of market readiness. So if you consider the word sentiment, a sentiment is a feeling, it's an emotion in a classical use. A sentiment is not a binary classification of positive, negative, or maybe three-way, positive, negative, neutral. But that is what has been computable, had been computable for many years. Positive, negative, very simple categorization, very simple to classify things into that. So sentiment analysis as a practice dates back, I'd say 2 decades. I have 2 images here from academic papers from 2003 and 2008. Again, I will provide my slides. You can go out and look at these yourselves. The idea is this is something that we have been grappling with, that we have found very prevalently in software that handles review analysis, that handles conversational analysis, that handles social media analysis. A sentiment classification is something positive, negative, or neutral. We do see variations on this where we talk about the intensity of the sentiment. Is it very positive or only mildly positive? There's a further understanding as the computing power has grown that we want sentiment not only at a document level, or for that matter, a tweet level or a review posting level, but we want sentiment that is resolved to a particular object. So here's a model put forward by another academic, Bing Liu, who's at the University of Illinois in Chicago, which talks about how to describe sentiment. You'll see here that Bing Liu, and he does relate this to different disciplines within natural language processing, talks about a differentiation between the sentiment object and the holder of the sentiment. So if you feel a certain way about, for instance, this building that we're in here, then you are the sentiment holder, and the sentiment object is the building, the hotel, the restaurant. We get into a further refinement where we have aspect-based sentiments. So, for instance, this computer that is in front of me has a screen with a certain resolution. It has a keyboard. These are different aspects of the particular object. So, for instance, at a restaurant, you might like the welcome. It is very warm, but the food you don't like so much, or it's very expensive. These are different aspects of the problem. So as the computing power has grown, the ability to be very specific and detailed to discuss the object of a sentiment has grown as well. Sentiment, we also understand, has a temporal aspect. It changes over time. The objects change over time. The words of meaning change over time. So this work by Bing Liu talks about sentiment. But let's bridge into emotion analysis. Computers have grown much more powerful in a number of sense. We've now have the ability to do what I will call arbitrary categorizations. We can categorize according to complex emotion models that do not have orthogonal categories for that matter. You can be both sad and angry at the same time, for instance. We can use supervised methods and GPUs and different emerging machine learning algorithms to handle much greater volume and complexity of data. So that's how we've been enabled to move into emotion analysis and not just binary positive, negative, neutral sentiment. So emotion models, as I said earlier, can be hierarchical. You can get a different level of refinement. It's really key to try to understand how what you are discerning in terms of emotion is usable in the business context. Does it actually help you make decisions and solve problems? So let's consider some examples that illustrate what I'm talking about here. What is this in this picture? You're seeing someone who is smiling. He's happy. Does that make you happy? Do people know who this is? So it makes me sad. It makes you sad. So this is a way of differentiating between an emotion that is felt by the person who is in this picture, who died about 2 months ago in a tragic accident, from the emotion that is induced here in you. I actually had another slide. No, I won't say that. So to continue, I want to have a very practical presentation, so I'm going to use a lot of commercial examples. Please do not take them as more than illustrations. Don't take them as endorsements. It's just much easier to find things that have been put out there commercially by people who have a capability of doing much nicer graphics than I do, rather than trying to create my own. So I use three examples here. Ipsos is a large global market research company. They recently acquired a company doing originally human-based evaluations of sentiment and emotion called Synthesio. Sensum is a company that's working in this space. But what you'll see in all three of these illustrations is the multifaceted nature of emotion sources. That, for instance, we can track something related to emotion. We can track attention via eye tracking. Are you looking here or there on a screen that's in front of you? We can measure physiological signals. We can code facial expressions to see smiles, frowns, other indications of anger. what's important here is to be able to understand not only a point in time, but understand how expressions change. We also, of course, have text as an emotion source and voice, as some of the speakers before me have discussed. So now I'm going to, in the next set of slides, break down the different sources here, again, using lots of examples to really help you understand how these things are analyzed and used. So before doing that, let's just differentiate three things in emotion AI. There's emotion understanding what the emotion holder, the sentiment holder, is feeling. There's also the sense of conveying emotion. How do I convey my personal state to you? And we'll extend that. How does a bot or an avatar convey a certain emotional state? And then the third thing is evoking or inducing emotion. How do I make you feel a certain way? For instance, if I show you a picture of Kobe Bryant, that will make certain people feel sad. I knew that in advance, so that's why I showed you that picture, to show you that example. So we do differentiate three different aspects of emotion AI here. Here's one more illustration. I see a few people laughing here. This is Donald Trump, who is famous for sneering, which is what he's doing here. He's belittling the people he is trying to mock. Some people like Donald Trump. I don't personally. The people who like Donald Trump are going to be like the people who are in the background of one of the photos here. They love what he's doing. They love it when he's making fun of his political enemies, when he's belittling, for instance, the coronavirus as a Democratic plot, hoax. They love it. So their reactions are going to be different from yours. You can see his gestures, however. This gesture here, this gesture, he's conveying his own appraisal. So let's get into actual stuff. So how do you do emotion? Often in natural language processing, dating back, again, a couple of decades, the starting place is lexicons, word lists. So in NLP, for instance, we used to use extensively, and we sometimes do, what I will call language artifacts, such as dictionaries or lexicons or gazetteers of places. You can create emotion lexicons, as Saif Mohammed in Canada at the National Research Center in Canada has done. You can go out to the site. He freely provides data that can be used for commercial and non-commercial uses for training. Here's one other shot of work that Saif Mohammed's done at the National Research Center in Canada to allow the interactive graphical exploration. This is an online tool that uses Tableau of emotion words and their interrelationships. Let's move on again. So what do you do after you have lexicons or word lists? You start doing some parsing. This is a classical NLP approach predating the kind of machine learning with BERT and so on that we do now. You do some parsing and you look for dependencies in order to see what emotion evaluations are linked to what emotion holders and objects and so on. So again, these are just illustrations. I have lots of slides here, and you can look further into this stuff as you go forward. We do see the desirability of having graphical representations of these things that can help you, of course, deal with large volumes of data, including language data. And for a final emotion and text slide, I decided to pull stuff from IBM Watson, their tone analyzer, just some illustrations here that show the kind of breakdown that they're doing. And that is not only of emotion, but it's of related concepts that help describe human communications and make it useful. Actually, I was wrong. I forgot I added one more slide. This is a particular commercial implementation. Sorry about the quality of this. This was a picture I took from a presentation a couple of years ago of one commercial tool, Clarabridge, which is active in the customer experience space. They analyze contact center voice recordings and so on in order to do emotion analyses. And in their case, a related concept is effort, customer effort. How difficult is it to conduct a given transaction? So an example here, as we get into the chatbot world, since this is the conversational AI track, this is a company, Core AI, that does chatbots. And you can see an example of the communications here in the lower right of the screen. I do note that while this says sentiment analysis, they have broken out of the positive, negative, neutral mode to understand that sentiment really is about emotion categorizations. Now, what they're doing here is an appraisal of each utterance, of each thing that is said by the agent or the person who is texting in. That is not dialogue mining. That is looking at the particular utterance. It's not looking at the sequence of communication that you would have in a normal dialogue. That is something that is still emerging. Let's move into voice in the sense of spoken words. Here's just a little bit of motivation from Nuance, a very prominent company in this space. Create a human voice for your brand. So we try to humanize brands. We try to humanize technologies. What is involved in analyzing speech? I would actually say that some of the talks prior to this one analyze this better in a technical sense. The idea, however, is that there are elements that convey emotion in speak. If I start talking a lot faster, that perhaps suggests that I'm agitated. If I talk loud, emphatically, that says that I'm trying to convey something that is beyond the words that I'm using. Maybe I'm going to pitch things in a different way. There are all kinds of cultural indicators that are involved here. For instance, in the United States, there was something called Valley Girl, and I'm not going to be able to do it, but you raise your voice as if you're asking a question at the end of each sentence. So what's the motivator here? I pull something from VoiceBot.ai, which shows that humanized voices, even though they're simulations, are going to elicit a much greater, a much superior response from the people that you're talking to. Once again, look at the stuff again yourself later. So what are the most prominent voice interfaces nowadays? It is stuff like Amazon Alexa or the various assistants on your phone and so on. These do not have the capability to independently synthesize emotion in what they convey. Instead, they rely on a markup approach. But once again, we have imperfect models. We improve them as the technological capabilities improve, as the compute power becomes cheaper, which it is doing all the time, as the machine learning capabilities become better. We have voice rendering that is starting to get into machine learning methods. Here's just an example here of some academic work that was done. Again, look at it yourself later. And there is software available that you can use to explore this. I believe this is not an actively developed project that's available out there on GitHub, and you can go out and get it and play with it. That is the joy of working with language that we all understand. Maybe you don't understand English as well as I do, but there are resources available, and you can see for yourself how well these things work and experiment with them. I'm going to skip that one. We need to start getting into ways to hook this into our contact centers, our voice response systems. Again, we have a few examples of companies that are providing SD system development kits, application programming interfaces as a service that you can plug these things in. We want to go further and try to fully automate the conversations. Here's an example from a company called IPsoft, which is possibly leading this field with their AMELIA product. If you go out to their site, you'll see that they not only try to animate, to humanize voices, but also to have customer service avatars that have human-like expressions. So I'm going to skip a slide and then go back. We also have these robots. I think they're silly, but in any case, that have the ability to have expressions. These are old examples, but they're getting better all the time. And part of how they're getting better is the availability of technologies like this EmoShape, which is a chip that is meant for embedding in devices or supporting online services to synthesize emotion. Finally, facial coding. I have an example from Affectiva here that's doing this for vehicles, cabin experiences. I'm highly skeptical of this for a number of reasons. One is that you have technologies like Mobileye that are non-invasive that have the same effect. They help induce safer driving. You don't need to have complicated facial recognition technologies with emotion analyses in order to conduct to meet the need successfully. And then there's also a lot of skepticism from, for instance, AI Now, which is an institute out of New York University, about the well-foundedness, the scientific well-foundedness of these emotion models, in particular for facial recognition. So we should naturally be very skeptical. I talked about bias before, but also about the scientific foundations. Still, these models I would characterize as useful and improving all the time iteratively, and important also for what we are doing in our business world. So finally, I'll just make a plug for two things, really. One, the conference I have coming up in 3.5 weeks in New York, perhaps of interest to people, getting a full day into these topics if you can travel. The London conference here, I'm going to be postponing because of the virus. And then some friends in Brussels, language technology industry, have an open call for presentations. I just thought I'd put that up here. That's not emotion related in case anyone fancies a trip to Belgium, and that's possible in late June.